Okay, welcome back, students. Let's get into section 8.7. Okay, 8.7 is on variation of parameters. Okay, consider the second order differential equation. Y double prime plus A1 Y prime plus A2 Y is equal to F. Suppose that Y equals Y1 and Y equals Y2 are two linearly independent solutions to the associated homogeneous equation Y double prime plus A1 Y prime plus A2 Y is equal to 0. Okay. Let YP, or the particular portion of the solution, be equal to U1 and Y1 plus U2 Y2. And we're allowing C1 and C2 to vary. Then U1 is equal to negative of the integral of y2 of x times f of x all over w of y1, y2 of x. And that's the Wronskian. Okay. And u2 is equal to the integral of y1 of x, f of x, over the Wronskian y1, y2 of x. Okay, and there's dx's here. dx, because we're integrating with respect to x. Okay, where w of y1, y2 of x is the Wronskian on y1, y2. Okay, thus, okay, the general solution y of x is equal to yc of x plus yp of x which is equal to yc of x is going to be equal to c1y1 plus c2y2, okay, plus u1y1 plus u2y2. Okay, so let's see how we can utilize this to help us solve a differential equation. Number one, solve y double prime plus y equals secant of x. Right? Okay, the first thing we want to do is look at the homogeneous equation associated with this differential equation. So y double prime plus y equals 0. Okay, let's use our differential operator. This is d2 plus 1 of y is equal to 0. D squared plus 1. Okay. Okay, and so y1, okay, is going to have some form of cosine of x, and y2 is going to have some form of sine x. Okay, when we try to solve this. Okay, and so okay, because the complementary function would be yc of x is equal to c1 cosine x plus c2 sine x. Okay, that tells me that I can find the particular solution here using the Wronskian and using those integrals. Okay, so let's first calculate the Wronskian. Okay, the Wronskian is going to be equal to cosine x sine x, the determinant of this thing. That should be determinant, not matrix. So, and then the derivative of cosine is negative sine. Derivative of sine is cosine. Okay, now we're going to take the determinant of this. This is going to be cosine times cosine minus negative sine times sine. And that equals cosine squared x plus sine squared x, which is equal to 1. Okay. Okay, so now let's find out what u1 is. u1 is equal to the negative of the integral of y2 times f of x over the Wronskian. And u2 is equal to the positive of y1 f of x over the Wronskian. Get my dx. Okay, so f of x, going back to the original problem, okay, is secant x. Okay, secant x is my f of x. Okay, so I'm going to have y2, which is cosine x secant x over 1. Is that right? No, it's sine. Sorry, my bad. It's y2 that I want. So sine x secant x over 1 dx, the negative integral of that. Okay. So this is going to end up being sine x over cosine x. Okay, negative. So if I let u equal cosine x, okay, I get du equaling negative sine x dx. Okay, then this just becomes the integral of 1 over u, which is just the natural log of u. Okay. Plus c, but we're going to let c be 0 because we only need one particular solution. Okay, and so this is the natural log of cosine of x. Okay, that's u1. Okay, u2 is going to be y1, which is cosine x times the secant of x over 1 dx. So this is the integral of cosine and secant are just going to cancel out. So that's just 1 dx. That just becomes x plus c, but again, let c equal 0. We only need one particular solution. Okay, and so this is just going to be x. Okay, so u1 is equal to natural log cosine x. u2 is equal to x. So the particular solution here, y prime, is equal to u1 y1 plus u2 y2. Okay, so this is going to be y1 is cosine x. So this is going to be cosine x ln absolute value cosine x. u2 is x, and that's times y2, which is sine x. So putting this all together, y of x is equal to c1, right, cosine x plus c2 sine x plus cosine x natural log of cosine x plus x sine x. And that's my solution to that differential equation. The general solution. Okay, let's try another one of these. Number 2. I have y double prime 4y prime plus 4y equals e to the negative 2 x natural log of x. Okay, so let's just look at the homogeneous equation associated with this. Y double prime plus 4y prime plus 4y equals 0. Okay, let's get our differential operator here. This is e squared plus 4d plus 4 of y is equal to 0. Okay, this can be factored into e plus 2 squared y is equal to 0. My polynomial equation would be r plus 2 squared equals 0. And so r equals negative 2 with multiplicity 2. Okay. So okay, the general solution or the general solution to the homogeneous equation, okay, or yc of x is going to be c1. Okay, it's multiplicity 2, so I have to take into account that there are two cases here. C1 e to the negative 2x plus c2 x e to the negative 2x. Okay, so y1 is equal to e to the negative 2x, and y2 is equal to x e to the negative 2x. Okay, so let's get our U's. Okay, and our Wronskians. Let's do the Wronskian first. The Wronskian is going to be e to the negative 2x, x e to the negative 2x. Okay, the derivative of e to the negative 2x is just negative 2 e to the negative 2x. And the Wronskian are in the derivative of x is going to be just derivative of the first times the second e to the negative 2x, okay, plus the derivative of the second, negative 2 times the first e to the negative 2x. Okay, now let's find the determinant of this. So this is e to the negative 2x times e to the negative 2x minus 2x e to the negative 2x minus negative 2x e to the, oops, got the e to the negative 2x, okay, times x e to the negative 2x. Oh, I forgot that there's no x here. This is just 2. Okay, so let's distribute and see if we can clean this up. So this is going to become e to the negative 4x. This is going to become minus 2x e to the negative 4x. Okay, this is going to become plus, so then, and then plus 2x e to the negative 4x. E to the negative 4x. Oops. So those two terms cancel out. And I'm just left with e to the negative 4x. Okay. Okay, so I have my complementary function. I need my particular solution. That's yp of x is equal to u1 y1 plus u2 y2. Okay, and so u1 is equal to negative integral of y2 f of x over the Wronskian. Oops. Okay, dx, and u2 is equal to y1 f of x over Wronskian dx. Okay, so y2 was that x e to the negative 2x. The f of x was in my original equation. Here's my f of x right there. Okay, so that's my f of x. So that's e to the negative 2x natural log x. E to the negative 2x natural log x all over e to the negative 4x. So boom, 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 those are gone. Okay, and I'm just left with the integral of negative, I'll bring the negative inside, negative x natural log x dx. Okay, this guy is integration by parts. So u is equal to natural log of x. U is equal to 1 over x dx. Dv is equal to negative x dx, and v is equal to negative 1/2 x squared. Okay, so v du is just going to become negative 1/2 x squared natural log x minus the integral of negative 1/2 x squared divided by x is just x dx. And so this is minus 1/2 x squared natural log x. Minus minus is a plus. And then that's just the integral of x, 1/2 x, that's going to be 1/4 x squared. Okay. Plus c, but we're going to knock out the c because we are going to let it equal to 0. So equal to 0. Okay, and so that's u1. Okay, u1 is that guy. Okay. What about u2? Actually, let me factor here. I'm going to factor out a 1/2 x squared. Okay, so 1/2 x squared times this is going to become x minus natural log x. Okay. No, no, this is just 1/2 minus natural log x. Okay. Okay, let's look at u2 now. Okay, u2 is going to be, okay, y1, which is just e to the negative 2x times f of x, which is e to the negative 2x natural log of x. Okay. And then all over the Wronskian, which is e to the negative 4x dx integrate. Okay. And we get these get knocked out. So that's just the integral of natural log of x dx. Once again, we could solve this using integration by parts if we wanted to. Let u equal 1. Actually, we want u to be natural log, I think. U is equal to natural log of x. Du is equal to 1 over x. Dx. And then dv is equal to 1 dx. And v is equal to x dx. So we're going to get x natural log. Oops, let me skip a line here. We're going to get x natural log of x minus the integral of x over x, which is 1 dx. So this is x natural log of x minus x. Okay, and you could factor out an x there if you wanted to as well. So this is equal to u2. So u2 could equal, okay, x times ln x minus 1. Okay, and there's a plus c here, but once again, we're going to eliminate that because we only need one particular solution. Okay, so yp, okay, of x is equal to u1 y1 plus u2 y2. So this is going to become 1/2 x squared times 1/2 minus natural log of x times y1, which was e to the negative 2x, okay, plus u2, which is x times ln x minus 1 times x, y2 is x e to the negative 2x. Okay, so I could factor out of that an x squared and an e to the negative 2x squared e to the negative 2x times 1/2. I'm going to distribute this back. This 1/2 is 1/4 minus 1/2 natural log of x, okay, plus natural log of x minus 1. Okay. So that I can simplify. This is going to become 1/2 natural log of x minus 3/4. And I get x squared e to the negative 2x. So that's y of p of x. Okay, so let's put this all together. y of c, okay, is right here. Okay, y of c, and then we'll just add on our y of p. Okay, and we'll get the general solution. So y of x is equal to c1 e to the negative 2x plus c2x e to the negative 2x plus x squared e to the negative 2x times 1/2 natural log of x minus 3/4. And that would be my solution. Okay. And if, I guess if you really wanted to, you could factor out a e to the negative 2x out of the whole thing, but I think that's good enough for right now. Okay. Okay, and that's 8.7. So I will see you in the next video. Okay.